In this video, we will talk about equation of an exponential model. So the equation is n is equal to p times a to the t power, where p is the initial value and a is the factor. The initial value p is always greater than 0. A can be less than 1, and if it's less than 1, we call this decay factor. And when A is greater than 1, we call this factor as a growth factor. Let's review a couple examples. Conduct the equation with the initial value 0.2 and factor 3.2. So we will start with a general formula n is equal to p times a to the t power. P is given to us, it says the initial value is 0.2, so P is equal to 0.2, and the factor is 3.2. Now we will substitute these two numbers into the equation, and we will get the final formula. N is equal to 0.2 times 3.2 to the t power. Let's try one more time. Conduct the equation with the initial value 2 and factor 0.13. So we will start with the general formula n equal to p times a to the t power. We read the problem again, and we see that the initial value is equal to 2, and the factor a is equal to 0.13. So the final equation is n equal to 2 times 0.13 to the t power. We will review two more examples, but the problem will be kind of opposite. The equation is given to us, and we need to find the initial value. The initial value is a constant 7.2. Now the factor is a number that is raised to the power. In this case is 1.4. And it's a good idea to say A equal to, this is P equal to. Now what do we see? We have to decide if it's growth or decay factor. A is equal to 1.4 and it's greater than 1, so this factor is a growth factor. And the last example, the equation is given to us. We need to find the initial value. The initial value is a constant. In this case is 107. The factor is a number that raised to the exponent. In this case, a is equal to 0.02. And we need to decide if this factor is a growth factor or decay. A equal to 0.02, less than 1, so we're talking about the decay factor.